So, what Christine and I are going to do today is go through serving meals, not ingredients. And basically what this is going to be about is transitioning from managing nodes to managing topologies in Chef. So just to kind of get things started here, we're going to really refer to meals as topologies and nodes as key ingredients of that. When we talk about topologies, they're made up of sort of four things for the purpose of this discussion. The nodes, the software that's running on those nodes, how that software is configured, and then how that software is connected. Tying all these things together actually gives people collaborating about the system a sense for its wholeness, how the pieces work together. When we talk about things like lean and agile and DevOps and those type of things, you want people to work together and they have to have a sense of what the whole is, and that's why we're dealing with the topology. So, we see different ingredients, and of course, given that we're at Chef, you always have to have a knife hanging around what you're doing to get things done. We keep working with that. So, the meal is the whole. Now, one of the key questions comes up is, how do you get this notion of a topology to kind of work with the current Chef infrastructure? What that really so the way we're going to sort of refer to that is emulating the topology in the Chef server. And that really starts with grouping nodes. And actually, there are a variety of mechanisms in Chef that you can use for organizing nodes or kind of grouping them together. You can use what you see over on the left-hand side. You can use the environments. You can use tags. You can use node attributes. You can use data bags. All these mechanisms are there. For the work that Christine and I have been doing, we're actually not taking advantage of those mechanisms in the work. And we actually created a new artifact called, we refer to as a topology JSON, which is something that goes in and out of a knife topo plugin. Now, some of you in the room are going, great, another artifact that we have to sort of deal with. We really had some specific reasons for actually doing that. One is, as we get into the scenarios, you're going to see that the scenarios we're talking about have to deal with an organization that's been used in Chef in a variety of ways, which means these mechanisms are probably already being used. So we wanted to minimize the collision with the way those mechanisms are being used today. We also wanted to be able to have this notion of topology as code. Because that's a file, it's now something that can have source control. You can kind of control this is the way the topology was at a particular piece of time and keep track of it as it changes through time. We're also optimizing for Chef. We could look at using other formats like Tosca and that type of thing, but we're really focusing it on Chef. And it also allows us to iterate faster as we work through these things. So now, that's kind of the setup in terms of what we mean by meals and ingredients. We're now going to sort of go into two scenarios for Jake and Fred. What you're seeing on the slide right now is the type of organization that Jake and Fred work in. So it's a multi-splat star enterprise. That meaning this is an organization that delivers multiple products to market through multiple channels. It does multiple things, and it's imagining it's going to keep doing multiple as a way of the enterprise growing. This means that there are multiple lines of businesses, and those lines of businesses have different IT systems that they're working with. Those IT systems are of the complexity that there are multiple deployments of those through a life cycle. Here we're illustrating the whole notion of life cycle or pipeline in terms of development, test, staging, and delivery. That sort of subliminal message behind here, there's actually a lot of meals going on in this type of enterprise. Because the different points for the different systems, at the different stages, different instances of that, you have topologies being deployed. The one other thing that I want to use to sort of set context before we jump into the scenarios is down at the bottom, technology adoption model. So this is just trying to show sort of typically what happens in an organization like this that starts adapting a technology like Chef. Starts with someone has to go first. Some team, some person using this first. Then there are a couple other teams that start using it, sort of the first wave of doing things. And then the organization says, you know what, this is actually working. This is actually providing some value. We should start driving more broader adoption and get more systematic about what we're doing. And then someday you might imagine doing full adoption. So where Fred and Jake are really dealing with things is in that transition from our first wave, you got a couple of different teams using Chef, but you really now want to drive more adoption across the organization, meaning you're getting ready to create lots and lots of more meals. So Jake's responsibility in this context is his charter is increase consistency across these teams that are using Chef without impacting their agility. Now, this, people will want to, the business will want increasing consistency in order to reduce costs, in order to share skills, in order to share content. I mean, that's part of the motivation for being consistent. Now, if you're on the other side, if you're not Jake, but you're in the other parts of the organization, and you have to start working with Jake and be more consistent, you're actually thinking about, well, wait a minute, what's this really going to mean? Is this going to mean more meetings? Is this going to mean I'm going to have less control over what I'm doing? All these things start poking at that agility notion in terms of how do I stay more agile. So Jake's sitting there going, great, I got this assignment. I need to be more consistent, but I can't impact agility, which means I can't really slow people down. And Jake's going, I'm not really quite sure how I'm going to do both of these things at once, but I'm going to get started and see what happens. So the work, I need to get more consistent. So what I've outlined here is a very simple set of steps or the type of work that would have to go on in an organization to become more consistent. First thing you have to do is go out and gather the information. What are people doing? What recipes are there? What attributes? Then you have to get it organized. If I get all that information from these different teams, how do I organize it? And then I got to organize and start making decisions. What do we want to be consistent under what circumstances? And then I got to figure out how do we push the changes out and then monitor or verify it. Now, when I start going through this list, there's these alarm bells that are starting going off in my head because I've really bought into DevOps, Lean, and Agile, and this whole notion of creating waste. And I go down through this list, and I think, this is going to create a lot of waste. I'm going to go to teams and ask them to give me data. I'm going to organize it. It's like, how does this really add value to the business? So I want to plant two seeds in your head for how to sort of address that type of problem. So the first seed comes from thinking about organizational design. So a while back, I was reading a book on organizational design, and a particular book by Jay Galbraith that I really liked because it talked about design the way I understand it as an engineer. It's a bunch of trade-offs. And in that book, he opens up and illustrates and says, in an organization, you can centralize a function. You do that to save cost and get consistency. You can decentralize the organization in order to have speed. Got that? Understand that? Now, he says, but there's a con. If you decentralize, those other teams don't know what the other team's doing. So I'm reading that, and then the very next sentence changed my way of thinking about IT systems. It says, well, when it's decentralized, teams can't see what other teams are doing, but that's why you have an information technology system, is to help them see what the other team is doing. So all of a sudden, it's like, well, wait a minute, maybe what the software should be doing or the tools that people are using is help them see what the other teams are doing without incurring additional cost. So that is really sort of pushing things more over onto the innovation side. It says, like if I have a way that I can do this consistency where other teams can see what other teams are doing, then they can be more consistent without that overhead task force and that type of thing. So the other piece that sort of changed the way I started to think about this is recognizing that an organization that's collecting data and sharing data, you want to pay attention to how close in the organization are the people who are supplying the data versus who uses the data. So if you have one team supplying another team data and they don't do anything with it, the data is not going to stay current. Or it's going to change because they're not getting any value out of that. So the basic principle there is when you're collecting the data that you're getting and putting into the system, whoever's putting it in there should get some value out of that. So that really drives 4 fundamental principles. One is to get multiple teams to work to make things consistent, you need a consistent model for how you're organizing the data. The second thing is when you put the data into that tool, whoever's putting it in there, they've got to get some local use out of it. It's got to help them do that or do something useful, or why would they keep the data up to date? The third thing is once the data is in that tool, it needs to be able to be shared frictionlessly with other teams. And then the third thing is once you're able to see data from other teams, you can integrate that into your model. If those things happen, then you start having more of an innovative approach to where the software that you're using is helping you do consistency across organizations without the type of waste that typically happens. So what I'm going to go through, what Jake needs now is a really understanding of how to sort of organize the information in a way that will facilitate those 4 principles. So that's really what this chart is really talking about. So in the product automate.insight from Third Waves, we organize the information in this particular way. So I want you to focus on the middle of the chart first. So in the middle of the chart, you have these blueprints or ways of sort of talking about what you want the topologies to look like at their different phases. So below the blueprints down at the bottom, you have the particular topologies. So if you have the topologies and the different groups are able to bring their topologies in, and then the software helps organize it into blueprints in the different stages, then you can start reasoning about the various pieces. So, if I work from the bottom up, you have the meals, you have the topologies, using something like topology JSON, 4 groups of topologies to define blueprints to sort of reason about what do you want to be consistent across those topologies, and the multiple users of the tools can see that. You do those for different phases, and then at the top you sort of have the overall bill of materials that we just sort of summarize what are all the recipes, all the nodes, all the attributes are being used. And it's very possible, and I mean it happens with automate.insight, that if you get that basic topology information out of Chef and put it in there, it gets very easy for teams to see what other teams are doing. And based on that, they can collaborate and derive more consistency without creating more spreadsheets, without moving a lot of data back and forth in ways that create waste within the organization. So, this is what we refer to as a topology blueprint and inventory pattern. So for Jake, if he can really take the information from the various teams and get it in this form, now they are able to make decisions about, at the inventory level, what should be consistent for all deployments of a particular business system. At the blueprint level, they can look across the blueprints and make sure those things are consistent where they need to be, and at the topology. So you're able to do multi-level analysis of what should be consistent. So that's sort of an example. At the inventory level, here you see being able to bring in information about the software, information about the attributes, the recipes, bringing those in to the tool and making it possible to say, these are the things we'd like to be consistent for all of the deployments. When you move down to the blueprint level, you really sort of get into, what do I want to be consistent, for my system test systems or my production system. And then at the topology level, you can work on what do you want to be consistent across the various nodes. So this really provides a way of, here, it gives us a way to get the information organized around topologies as those meals. Then we're able to start making decisions at different levels in terms of what we want to be consistent incrementally. And now Jake has an approach that allows him to really get started. Finally, you got to be able to go gather the information. The way this really happens in this particular scenario is using Knife Topo, this plugin to Knife if you give it a list of nodes, it'll turn it into that topology JSON. It makes it very easy to bring it in to automate that insight. So the whole gathering of the data is actually fairly straightforward. And then as you massage and modify things and automate that insight, you then can use Knife Topo to make those particular changes back into the chef server. If you change some recipes and make them more consistent, change some attributes. So in this particular enterprise, this is really what Jake has been working on to drive some consistency using some software that actually helps the different teams work together, and you can do this in a systematic mode. So now we're going to worry a little bit about what Fred is doing. And to tell you about what Fred is doing, I'm going to hand it over to Christine.
Thank you, John. So I'd like to use Fred's scenario to do two things. The one is I'd like to tell you a little bit about some work we've been doing to integrate our Automate.Insights product that John was talking about with chef provisioning, and what extra that then lets you do. The second is I'd like to come back to this notion of a topology template like the topology JSON that John was talking about and its potential value to the chef community. So let's join Fred. Fred is one of the technical leads in the IT organization that John was talking about, who's had some success in bringing consistency to Coolco's core business systems. Meanwhile, like is happening in a lot of the industry, there are people in the lines of business trying to innovate and deliver the first generation of applications deliver new generations of applications rapidly. And what's happened is a bunch of shadow IT projects using a range of technologies, a range of providers has sprung up. And so basically what Fred has been asked to do is go work with those teams, help them adopt Chef, become more consistent in their service delivery, but obviously do not impact the business agility that they currently have. So Fred goes and meets with one of those teams, and what that team has is a social marketing application, which they called Hookem. And it's called Hookem because it's all about catching the people who browse their website and actually converting them into customers. It could also have something to do with the fact that we're both from Austin, Texas. Anyway, their system, it's a fairly simple standard system running in AWS. It's got a load balancer feeding an application server, which is running in an auto-scaling group, and it's got a back-end database service. So this Hookem team, they've adopted CloudFormation for deployment. And if you're not familiar with CloudFormation, it's a service in AWS that lets you define a set of AWS infrastructure resources in a template and then deploy it multiple times in what's called a stack. And over on the left-hand side, there's a fragment of what the template looks like. It's basically a JSON document, and it's showing the particular load balancer they were using. And so this CloudFormation template is really valuable to this team because it lets them rapidly and consistently deploy their test topologies, and then when they're done, they can clean up and they don't get any unexpected charges. So he talks some more to them, and he finds they've actually got some challenges as well, and those challenges really cut in when they start getting to what the software they need to put on that infrastructure to actually run their business. So when they need to actually set up the middleware and the applications. And what's in this gray box is just a snippet of the hundreds of lines of scripts they've actually sort of crafted into that CloudFormation template to start up and configure their software. And as you can imagine, this is actually quite hard to test, and it's even harder to maintain. And what makes it worse is the person who actually did it's just left the organization, and so they're struggling. Now, what they would have really liked to have done is replace that with something which bootstrapped Chef within the CloudFormation initialization, but they haven't actually managed to hire the skills to do that yet. So as Fred and his team talk, what emerges is a shared goal that they want to achieve. And it's got three main parts. The first is the team really wants to benefit from the chef expertise in the rest of the organization. They want to be able to use the central chef server. They want to be able to reuse the organizational cookbooks and the practices. They want to use the test tools. They want to use the continuous integration pipeline that Fred's team set up. The second thing they want to be able to do is to use chef provisioning to now actually deploy those complete topologies and have it all integrated into their chef configuration management. Because that would actually be far better to them than having to switch between two tools, the CloudFormation and then Chef for deploying on top, even if they had managed to do the work with Chef to bootstrap it. And the third part, in order to make that happen, they need to move from their CloudFormation templates to something else. And what they chose was this Topology JSON, but with the right tools around it. And what those tools needed to do was to convert from those existing CloudFormation templates first. Second, generate the provisioning recipes that they needed. And third, provide an interface for the solution deployers who weren't deep chef experts, but really needed to be able to customize and update those topologies. So with that shared goal in mind, this is what they did. Now, 3 steps. First step was to set up a system inventory. Fred did this for them, specific to the Hookem team in automate.insights. The second was the Hookem team could then create blueprints from their existing CloudFormation templates. And then the third is then they're in a position to start creating topologies and provision them using the generated recipes and chef provisioning. So I'm going to talk in a little bit more detail about those 3 steps. So first step, what Fred did here was take the subset of recipes, organizational recipes and recommended attribute values that was relevant to that Hookem team. And over on the left-hand side, you can see he basically brought in the recipes recommended for Node.js, MongoDB, and a Node sort of general Node application deployment. And he also brought in the attributes, not all the attributes, but those attributes that were recommended for customizing the deployment of those software. Then over on the right-hand side, you can see the recipes he brought in as part of the system inventory, which were the recipes for the software, plus some of the other recipes that the Hookem team would need, depending on the particular context of the blueprint. So, for example, the company chef handlers for monitoring and the chef client configuration. So what this means now is the Hookem team has this system inventory, and when they start defining their blueprints, all they need to do is draw from that inventory of the software that they actually need, place it on the nodes, and it'll bring in the recommended recipes and values. Of course, then they can customize them to the point that so they have a blueprint the way they need it. So of course, the second step is actually to start creating these blueprints. And to do that, they took their CloudFormation template and they used a utility called Topo Provision to generate the Topology JSON, which they could bring in to the automate.insights tool. What this looks like when they've brought it in is shown over on the right-hand side. So basically, for each of those key infrastructure resources in the CloudFormation template, it's created a node type in the blueprint. So there's the database server node, the application server node. That's what was implemented in the autoscaling group, the load balancer, and a special node for the chef provisioner. And if we could switch and look at the attributes, what you'd see is it not only brought in those things, but it also brought in the relevant provisioning properties from the CloudFormation template and put them on those various node types. So now all they have to do is, picking from the system inventory that was set up, specify the software, which node type should it be on to bring in those chef recipes and recommended values, do their customization, and they now have a blueprint from which they can start creating topologies. Okay, so the third step, they take the topology JSON for their topology, again use this topo provision tool to generate chef provisioning recipes for deploying and undeploying, basically for destroying the topology. They can now run that with chef provisioning. Chef provisioning will go and create the full stack, so the infrastructure resources as well as the application and the middleware. And of course it's chef, so they can rerun it if they need to. If they want to check that that topology is still in the desired state, they can rerun the recipe. If they need to update it, they can change the topology JSON, regenerate the recipe, run it, and it'll update that topology. Now, not only that, because that topology JSON is data sort of externalized and not sort of embedded in some code, the topo provision utility can actually do more than just generate the recipes. And so down below, we've got sort of outline of what was generated by the topo provision. So first thing it did was basically for each of those node types you saw in the blueprint, it generated one or more resources in the recipe. And exactly what resources it generated depends on the environment you're going to. Are you going to Vagrant? Are you going to AWS or some other cloud? So it would have some intelligence about which resources to generate and which properties to put where. The second thing that the topo provision tool currently does is it looks through the attributes you specified, and if you specified that a node attribute actually needs to be based on an attribute in another node, it'll generate the lazy search code for you. And it'll also use that information to order the resources in the recipe so that what you need to be there first is there first. And I think there's a whole load of other intelligence that you can build in as soon as you externalize that data in a way that tools can reason about it. So to just recap on the transition that the Hookem team's been able to make, they've moved from, they were using CloudFormation, that gave them infrastructure templates, made it easy for them to create and delete stacks. They were able to customize it at deployment time by changing parameters. And what they've shifted to is using the topology JSON, which covers the full stack in a uniform way. They were able to convert to it from their CloudFormation templates. And then using chef provisioning, they can deploy and undeploy the topology and they can update it. And it's all integrated with their chef configuration management. They've also got, from the automate.insights tool, they've got an interface that's usable by system deployers who aren't deep chef experts, so they can customize attributes and run lists and have the topologies the way they need them. And they also get some of the capabilities that John referred to, so they can get a line of sight and look across what's going on across a range of topologies and look at whether they're consistent, look at what was different and whether it should have been. And there's also assistance in automate.insights, so when you actually need to go change some value and propagate it all the way through all the topologies and all the nodes, it helps you do that. And probably most importantly, they're now able to benefit from the chef expertise in the rest of the organization. They're able to reuse the organizational cookbooks, and they're able to benefit from chef's awesome test tools. So just want to step back and go back to the notion of a topology template for a couple of minutes. So if you may have noticed in the industry that there are actually more and more people talking about using blueprints or templates for deployment. And I mean, probably the most visible CloudFormation that I've been talking about, Cloudify's implementation of the Oasis Tosca standard, HashiCorp's new Terraform project, and there's a bunch of other vendors, and I'm pretty certain there's quite a lot of homegrown implementations out there in organizations. I believe there could be real benefit in the community adopting a chef-oriented template format like the topology JSON that supports multiple providers. Because if we do that right, We'll get some amount of portability across those providers, but we can also build out libraries of converters from the other formats. We can build intelligent generators that help people not just, say, create chef provisioning recipes or other artifacts to go to the chef server, but also you could imagine you could use it to generate test environment definitions to go into test kitchen. And then the third value, so third parties can integrate into the whole ecosystem using the topology JSON like we did with automate.insights. So that concludes Fred's scenario, and I'd like to hand back to John.
Thank you, Christine. So we've been, serving meals, not ingredients. We went through, the life of Jake, who was really charged to go increase the consistency across teams that were using Chef without affecting their agility. And fundamentally, the way Jake went about doing that without creating more waste within the organization was to leverage some software that actually made it possible for him to overcome the classic challenge that occurs with trying to do increased consistency when you're working with a decentralized team. And then we saw how Fred took advantage of a template designed to work with Chef, took advantage of the awesome capability of Chef provisioning to work with a team to get them excited about using more and more Chef capability. So as the organization is going from that first wave of adoption to broad adoption, these are two scenarios in terms of the mechanics of actually increasing that. So with that, both Christine and I would like to thank you for coming and listening to Serve Meals, Not Ingredients. If you're interested in finding more about automate.insight, you of course can go to our website and a free trial. There's also references to, if you really want to participate in some of the open activities that Christine talked about, we're very excited about those. We really wear kind of two hats in this discussion. One is there are a set of things around knife topos that, how do you do topologies around Chef, that be done in an open way. And then obviously, as a company, Third Wave Insight, we also have a product that we're interested in discussing. So with that, I'm going to wrap it up. If you want to, I can't see the facilitators. So I think we're...
Yeah, it seems like you're a little ahead of schedule, so if you want to do some questions, we do have time.
Oh, okay. All right, cool. So we're going to open it up. Does anyone have a question?
So the concept of dynamically generating recipes is new to me. How does this work with Chef Client and Chef Server, or do you only run these generated recipes on Chef Solo or Chef Zero?
You could. So the recipes are being generated specifically that they work with Chef provisioning. You can actually run that in local mode, or you could set up a node which ran them as actual recipes. You can actually do either.
Any other questions?
Sorry, do you have a lead or a pretty complicated example of a topology JSON? Or like a couple of snippets? I'm curious to see one that actually expresses the full application.
Come and find me at our table, and I'll show you one.
Yeah, we don't actually have it to show here, but we're in the partner area, and Christian would be more than happy to show you one with gory details.
And I meant to say, if anyone is interested in the topology JSON and building something around that, please do reach out to me.
Okay.
All right. Well, thank you very much for coming, and enjoy the rest of ChefConf.